Okay, in this video we're going to look at the intersection of a quadratic function with a line. So we've got solve the equations y is equal to x squared plus 4x minus 5 and 2x minus y is equal to 1. So writing down the first one, I'm labelling number 1. This is a quadratic function, as we already know, and we know that 2x minus y is equal to 1. We'll label that 2 is a line. Right, so we start with the line, and from 1, which is 2x minus 1 is equal to 1, what we're going to do, we're going to add y and take 1 from both sides. That will give me 2x minus 1 is equal to y, i.e. either make x or y one of the subjects. Now because y is now the subject, I can now substitute that into 2. So instead of y, I can now put 2x minus 1 is equal to 2x squared plus 4x minus 5. So this is going to lead to a quadratic. So we need to rearrange it so we can solve it, and to solve quadratics we need to be in the format ax squared plus bx plus c is equal to 0. So subtracting 2x and adding 1, we're going to get 2x squared. 4x take away 2x gives me 2x, and minus 5 plus 1 gives me minus 4 is equal to 0. Now because 2, 2 and 4 are all divisible by 2, we divide by 2, so we're going to get that 0 is equal to x squared plus x minus 2 is equal to 0. So we now either solve this using the quadratic formula, or the completing the square method, or factorization. It does actually factorize quite neatly. So we've got x and x. The factors of 2 are just 1 and 2. So we want plus 2 and minus 1. If not, you'd have to use the product sum factors method. So either x plus 2 is equal to 0, which gives that x is minus 2, or x minus 1 is equal to 0, that gives x is equal to 1. Therefore, this line will meet this curve at two places where x is equal to minus 2 and x is equal to 1. To find the y-coordinate, it's best just to substitute back into the line. That's the easier of the two equations. So when x is equal to minus 2, we're going to get 2 times minus 2 minus y is equal to 1. That gives me minus 4 minus y is equal to 1. Adding 4 to both sides, we get minus y is equal to plus 5. Don't forget that's going to be minus y, and therefore y is equal to minus 5. When x is equal to 1, we're going to get 2 times 1 minus y is equal to 1. And then for 2 minus y is equal to 1, and therefore minus y is equal to minus 1, which gives, dividing through by minus 1, y is equal to 1. So we get solutions. The solutions are when x is equal to minus 2, y is minus 5, and when x is equal to 1, y is equal to 1. Now if we look at this geometrically, here is the quadratic. Okay, and this again I'll put in the notes of the video. This is when x is minus 2, y is minus 5, and this is when x is 1, y is 1. So it meets in two places. Now if you look at this diagram, the line could either meet just at one point or not at all, and the discriminant will tell us about that. And the discriminant we need to use is, we need to look at this equation here, okay, to work out the discriminant of this equation here. And if it's positive, then we're going to meet at two places. If the discriminant is 0, then it just meets at one place, and then that line is then called a tangent, which we'll look at later in the course. And if the discriminant here of this equation is equal to a negative number, then there's no solution, therefore the line and the quadratic function do not meet. So let's just have a quick look at this case. So if we look at the discriminant of the quadratic equation formed at the point of intersection, that equation was 2x squared plus 2x minus 4 is equal to 0. Therefore, compare that with ax squared plus bx plus c is equal to 0. We're going to get a is 2, b is 2, and c is minus 4. The discriminant we get from b squared minus 4ac, and therefore we're going to get 2 squared minus 4 times 2 times minus 4. Be careful substituting in negative numbers. 2 squared is 4, A minus and a minus make a plus, and then 4 times 2 times 4 gives me 32, which gives me 36. So the b squared minus 4ac, the discriminant, is positive in this case, therefore this means we have two distinct roots, therefore the line will meet in two places. We'll just go back to this for 1 minute. If I move the slider, maybe this one, you can see here the discriminant it meets in two places. Once it stops meeting in two places, the discriminant has become negative, and then it will be negative. So moving back this way, we'll have to move it back as a decimal. So just change this 1 second, the properties of this, just 1 second. Let's just change the properties to this to something a little bit smaller, the increments, and then we'll see if we can get it to meet in one place as well. And then, so you can see I could probably just get it to meet in one place doing it like this, probably. Okay, so we can see the discriminant there. At that point, the discriminant is equal to 0. This line just touches the curve at one point, and therefore this line actually has a special name at that point. It's called a tangent, and we'll look at that a lot more when we do calculus. Okay, so this has been a video to show you how a line, what happens when a line and a quadratic intersect. They can intersect in two places. One place, like we've got in the diagram, which means it's a tangent, and if it doesn't intersect at all, then the discriminant will be negative. So the rules of discriminant apply to this as well. I hope you've understood, and I thank you very much for watching.